Good evening, ladies and gentlemen, and welcome to the Halifax and District Amateur Radio Society's first inaugural meeting for 2025. Should have been last week, but as we know, it snowed. Anyway, so what I'm going to do this week is to talk a little bit about constructing your first project and why we should be constructing our first project. Why we should get into construction. And there's a whole range of things we can build. You can build circuit boards, antennas, you name it. The whole world is out there for your discovery. But I thought I'd put a few notes down for people who've felt a bit reticent about getting into construction and finding out what's actually involved. So why do we build stuff anyway? What's the reason for this? Well, we can't buy exactly what we want. I mean, this is a classic example. We had a couple of portable events a couple of years ago, I think, been up at Eric's farm, and everybody was on different frequencies on HF, and we're getting bad breakthrough. So I looked round to build a bandpass filter. Made 4 of them for 7 megs, 14 megs, 21 and 28 megahertz. Couldn't buy them anywhere else, at least not at the price I could afford to pay. So I built this, and it's a little tiny Butterworth 3-pole filter, and it cost me, what, 5-6 quid for the box, and maybe another £5 for the components. I had the plugs and sockets. It's about a tenner. So it's a very good, very effective bandpass filter. Didn't cure all the problems, but it went a long way to doing that. So we can't buy exactly what we need. We have the human urge to build and create and tinker. That's what we do. We try and build stuff. We want to do this kind of thing. And we want to learn new skills and expand our hobby interest. So if you've just been operators, you just go into the hobby through a new license, trying these new adventures, these new fields will give you a bit more richness in your hobby. And we're curious and want to have a go ourselves. You see other people doing it, how hard can it be? And it's not very hard at all. So all these and 100 more reasons are fully justified for actually building things. So why don't we build stuff? Well, one of the first reasons, it's a lot cheaper. Actually, no, it's not. At least not at first. If you're starting to build something from scratch and you have to go out and buy every single component, often at 5 or 6 or 10 items at a time in a packet, you only want one, so it's not cheap. But as you build up your stocks over the years, it gets cheaper. Because we don't know where to start. But of course, lack of knowledge is not stupidity. It's just a question of getting trained and getting some experience. Because we don't think we have the ability. Well, again, lack of training and guidance is not lack of ability. So the point of the club is to try and give you that training and guidance if you want it. That's what we're here for. And I don't understand the circuit. My knowledge of electronics is poor. Actually building and testing the circuit is the best way of learning. You can find out an awful lot more by building a simple circuit, using a multimeter. You don't need much more than that. Figuring out how it works and just staring at the circuit diagram, you'll actually find out a lot more than you would do if you just tried to read it out of a book. I'm not very practical. An excuse I often hear. I used to hear it at school. I'm not very practical, sir. I can't do this. Actually, we're not all born with a natural gift. Some people are, but not many are. We have to be trained. We have to be shown. We have to be tutored. Again, that's what we're here for. We need some basic tools. So what do we need? Well, not hundreds of pounds worth for a start. If you are starting in electronic construction, we need a set of flush side cutters. These are about 15 to 18 pounds, and they'll last you a lifetime. These are Nipex or Nipex, I'm not quite sure how you pronounce it. Flat cutting side cutters, they ground flat on the bottom and have a V coming down to the base like that. So it cuts very flush to the board, hopefully not too close. We need a pair of small long-nose pliers, bending component leads and picking things out of boards. We need a pair of wire strippers. I prefer these with the pre-drilled holes in them. I find them a lot easier. There are many different types out there you can try. Some people prefer different types, automatic ones, but this works very well indeed. You'll need a small set of electrical screwdrivers, cross point, flathead, and a solder sucker to get things out when you put them in wrong. So a good solder sucker. This one here is from Japan Engineer brand tools. It's a really good solder sucker. On the end down here, we've got replaceable silicone rubber tip. It comes in a long length. You just shove a new piece on. If you've ever tried one of those old types with a molded Teflon tip on them and it gets all gnarled up and it's jiggered after a couple of weeks, this is very, very good. It's got a good pump action, very, very fast, lots of vacuum, and it works. And something to make a solder joint. Something like this. This is an Antex C15 iron. They do a whole range of these. range of around about 12 to 15 watts. You can go up to 25 watts with them for small circuit. But something like this, you don't want anything much bigger in a fixed temperature soldering iron, which is this is. It won't do all the jobs. It will do a few of the jobs. This small circuit board here, this is the Little Roo 40-meter receiver from Kanga Kits. And you can see that it's got some standard, what we call through-hole components. And there is on the end of it a rather large BNC plug made out of solid brass. And I'm afraid that that little iron there won't have it. It simply won't heat it up enough. These pins at the side, it's a problem with all the Kanga kits. They put these huge, great cast BNC plugs on them, and they need a bigger iron. So you may need 1 or 2 irons depending on what you're doing. If you're putting on an old conventional type of BNC connector, sorry, a PL259 connector, to solder the braid, you're going to want an iron of around 70 watts. So you do need a range if you're going for a fixed iron. So a 25 or a 15 watt iron with a 2.3 millimeter bevel tip, that's just, you see the bevel going up just one way, will handle most PCB work, and adding a spare conical tip will allow you to get into little tight corners like IC chips and things like that. So it's a good investment. It costs about £38 thereabouts, along with a soldering iron stand. A 25 watt iron is considered the minimum to deal with larger components. So at least 25 watts to solder something like that on. If you're dealing with large 20 amp connectors and you want to solder those, you're going to want something a bit bigger than that. So you can save money by buying a cheap iron. If you do want to solder a wide range of things, then consider something like a soldering station. They are more expensive, but they have a 75 watt iron as a minimum on them. But they've got some very small tips. A lot of heat can get down to that tip and handle bigger jobs. So, it's false economy perhaps to think that buying a cheaper iron will solve all your problems. Keep the soldering iron clean and tinned, and use safe, of course. It's red hot. So what we need to do is to buy a soldering iron stand which fits the soldering iron. Now, next week I'll be talking about soldering irons and soldering, and I'll bring along some examples, good and bad. This little soldering iron stand here is designed for the Antex irons. It takes the sort of the 12 to 15 watt irons. Any bigger and it starts to cockle over. What we don't want to happen is for the soldering iron to cockle over and touch this protective guard spring here. If it does cockle over and touch the spring, what happens is that the iron never turns off. It's supposed to be cycling on and off at about 360, 400 degrees centigrade, and it doesn't. It stays on all the time, and the heating on it lasts no time at all. This was a big problem in the schools where the kids used to leave them on the bench and then shove them these things. They used to go black at the end, a real mess. So it's not a good idea to buy a soldering iron stand that doesn't fit. Make sure it holds the iron safely and doesn't allow it to be knocked off the bench. If you're working in a cold workshop, as I often do, you've got a PVC lead on your soldering iron and you've wrapped it up like that before you went to bed 3 weeks ago, it's going to come out like that and not actually unravel. So as soon as you catch it, it's going to fall off the bench. We can use a soldering iron tip cleaner. These copper wire or copper braid tip cleaners are very, very good. They tend not to cool the tip down as much as a wet sponge does. You need to be able to wring that sponge out really well, otherwise it'll quench the tip and then you'll have trouble soldering. And some of this stuff called Weller tip activator. It comes in a small tin, and it's a paste or a powdery mix of solder and flux, a bit more aggressive than you get in the cord solder. It's designed for cleaning that tip and then tinning it, which is making sure it's free of oxide. A quick dab of that now and again, not every time, just enough. And we're going to use some tin lead solder. Tin lead solder. It was designed in the arc, this stuff, and it's now in industry being phased out, significantly phased out, because of the lead content. It's about 40% lead, and they don't like that. But it melts at a low temperature, and its flowability is extremely good. So for beginners on circuit boards, tin lead solder is far superior to the new tin, silver, and copper alloys. So use that, and the tin, silver, and copper alloys melt at a much higher temperature as well. So it's always difficult to get to take. So if you see this, PB, that's a sign for lead with a bar through it, or it says on there tin lead or whatever, a tin silver, avoid it initially. It's very hard to find, but just make sure that when you go to an advert, you are actually getting tin lead solder, 60-40 tin lead. So where do we start? Well, we need to find something that you want to build, I want to build. And this is something I was messing around with the other day. This is a small RF probe. I was looking at a transistor radio to try and get the thing to work, and I needed to listen or just sniff for the RF and the audio coming through the stages. And I found this in a magazine. It's a little tiny junction field effect transistor with a few components and a couple of diodes as detectors. So this thing will listen to RF all the way through the RF stage. And it's built on a piece of strip board or Vera board. Now, not everybody will be able to take to this straight away. I suggest you don't just jump into something like this, but that's what we're here for, to try and train you and show you how it's done. You can download a copy of a piece of strip board, or you can work on it in pencil. Try out the various components, try breaking tracks and jumping links across to get the circuit to work. It's a bit like doing Sudoku. After a while you get the hang of it, it's in your head and you just do this automatically, but at first it's a little more difficult. So going from scratch, you can try your hand at this, but it's not that difficult. It's a bit like Sudoku. It's just a mindset and it's practice. But it can be expensive, as I said earlier, because if you are starting from scratch, you'll have no components. So not only have you just bought yourself a soldering iron and all your tools, you're then going to buy at least 10 packs of boards from Amazon, because that's what they come in from China, 200 electrolytic capacitors, because that was the bag size it's sold in by Radio Spares, and all the rest of it. And you'll think, that's 90 quid, what on earth's happening? So, but because that'll last you a lifetime, and doesn't, you die and all this stuff gets handed on to somebody else, which is why every time there's a silent key sale, you get sacks of the stuff, right? But this is what you do. So, get kitted up. If you're going to build something, first of all, buy a kit. This one is an audio signal tracer. It's really, really cheap. And what it does is, if you've got a transistor radio or any circuit where you think you have audio issues with it, you can replace the audio amplifier in the equipment and just use this as a probe and start listening around to find which transistor is dead or which transformer's gone down. Incredibly cheap. These guys buy all the components, thousands at a time, and sell them you 2 or 3 in a little tiny bag. And everything you need is included, except perhaps the hardware. It just doesn't come with a box or a speaker, but you can buy those at Amazon. And it's already been tested, and it'll include detailed construction notes. So everything's there for you. The components are there. The board is there with the board silk screen to show you where the components will go. And it's got all the construction notes. And a very good one it is too. This is a Velman kit, now available as Velman UK. And it costs 12 quid. All that, potentiometers, nuts, bolts and screws, 12 quid. You cannot go wrong by buying a kit like that. If you go into the Kanga website, once it reopens, you can buy some quite amazing kits. This is the Kanga little rule receiver, and there are dozens of them. The Kanga site is very heavily weighted towards QRP and CW, so you find a lot of Kias on there, CW transmitters, but there are some nice little kits to start off with, just to get you building. 29 quid for that. There's no way I could not order these parts and go out for anything like 29 quid, including the circuit board to build that. I'll be looking at least double that, at least. So kits are very, very good value. Get organised. This is the most important thing with a kit. Don't just tear into it. If you built something before and you go, I don't need all this rubbish, I'm just going to sit there with a resistor and rattle stuff in. I'll put the plug in first, that's the thing to do, because when you put the plug in, you can't get the potentiometer next to it, because you should have done that first. So lay out the bits, and Kanga kits are built in stages, and each comes in a little bag. You get the circuit board, all the parts you need for that part of the kit, and the DC lead. So you read the instructions, carefully follow it, make sure you know what the components are, read and label them, build it one stage at a time, follow the instructions and test it. It's all there in the instructions. Print off the component sheets, especially capacitor and resistor codes. Now Kanga usually send you a resistor color code sheet, but you can get them off the internet. They're everywhere. Get a magnifier, a small loop, or one of these fold-out magnifiers, about 10x, no bigger than that, otherwise you'll not see anything. Because some of these small capacitors defeat me these days, I'm afraid. These are tiny little writing, and I really have to struggle with these. Get a storage box. Put all your bits in the box. If you leave it out on the bench, you will lose things. It will fall on the floor. And if you put it all back in the bag and shove it on a shelf, you are doomed. So keep a box, put a lid on it. There we go. Follow the instructions and put it in the box. It's there for next time. All the bits are there. Component keys. Straight off the internet. All you need is a resistor color code list, and unfortunately Some of our resistors now have some rather curious colour codes. If you've done your foundation or intermediate licenses and you've found the 3-band resistor colour code, you suddenly find now they are 4 and 5 bands. But get a list, it tells you what's going on, and especially capacitors. 104, yeah, that's 10 and 4 zeros, PF. So these will tell you what the units are, what the operating voltage is, what the tolerances are. It's all on the packet. So if you just download these, you'll be able to identify components very easily. Free off the internet. And what goes in the board might have to come out again, because you will make mistakes. The whole point of this is you will make mistakes, and you're making mistakes in a safe environment. Safe environment because you've got people who've made mistakes before and can actually get those things out again with professional desoldering pumps. So when you put the component in, just make sure you splay the leads over just a little bit, just to stop it dropping out. You don't want to be hammering those leads over, because you'll be cutting them all off and soldering them and say, Max, it doesn't work, and I can't get it out without using a rock drill or something to get the leads off. So just bend it over a little bit and then solder it, and then we can get it out again if there's a problem. Moving a component is much, much easier with the leads bent flat to the pad. That's obvious, because once it's soldered, you start jacking the leads up, the pad will come up with it. Multi-pin components, and there are a few in here. You can hold it in, for example, this little IC socket here. Bend it in, just bend one over and anchor one corner. That way it won't fall out of the board. And then if it's gone a bit on the wry, you can put your finger against it, heat that joint again and push it flat. Then you can work your way around the pins. So just a little bit of methodical working with these things, and it makes it a lot easier. Photograph your work. Can anybody see what the problem is on this circuit board? That's the finished one. That's the board. Look at these resistor numbers. Look where they are under these resistors. If I hadn't photographed that board, and I end up with a spare resistor, I'm going, oh heck, where's it come from? Which one should it be? R4, where's R4? Well, it was there. So photograph your work as you go along. You'll thank yourself for it, as I did with this one, just to be on the safe side. Protect your eyes, your skin, and your furniture, and other people, in that order. Have a look at the photograph on the left and have a think about where that wire is going to go when I cut it. It's going to come bang straight out there, and it does come out of a real half of these wires will go right across the room. So make sure you tilt the board away from your eyes, away from the cat and your coffee. Make sure that where it goes, keep your finger on it and hang on to the wire, because it does go a long way and they are sharp. Most of all, enjoy the process as much as the destination, because it is a process. No point in rushing headlong and say, finished, now what? Enjoy the process, learn from it. This is supposed to be fun. This is progressive hobby. You will make mistakes and you will make a mess. We are here to fix that and let you learn. Only by making mistakes do we really gain that most precious attribute, which is experience. After I've been in a workshop since I was 15 years old, I've made every mistake there is to make and a few more besides that. So you learn from that. Ask for help and advice. There are members who can and will help you with any engineering and all the other stuff like drilling holes and getting stuff to fit in the box, which can be quite difficult if you haven't got a pillar drill, for example. You've got a 1/4-inch plate. So do ask. And don't miss the Haddars, pronounced the club name right, the Haddars Soldering School on the 28th of January. There we go. We will show you how to use these irons, how to solder onto a board, and what the differences are. You'll have a go yourself. I'll bring some boards, some bits of wire and components, get stuck in and have a go. Now last week we should have been having the year ahead, and unfortunately we were up to our necks in snow. So I've done a few slides at the end of this one, very quickly to tell you what we're doing. So on the 29th of January, the solder school. I hope I've got the date right. First-hand demonstration of soldering techniques, advice on which soldering iron to buy, which accessories to go with it, and try your hand at making a solder joint. I've got lots of these little tiny pad boards, come from China, cheap as chips, 12 quid, 40 boards, can't go wrong. Desoldering components from the circuit board, how you get them off again, I'll show you how to do that. And on Tuesday the 4th of February, Hardy will be showing us the VNA Revisited, which is how this amazing little device has invaded amateur radio. So we're looking at the most useful but possibly the most misunderstood pieces of amateur test gear. How to set up and calibrate, take single and dual port measurements, and how to tame and read the Smith chart display option. We are doing that. I'm looking over at Hardy. Yes, he nodded. Good, we got it. Right. On the 18th of February, an old friend of mine here, the Trans Match. And this is a much disregarded antenna matching unit these days. They used to be very, very common, the Trans Match. Made by SCM, and Richard G3UGF had a part of help in this because one of his colleagues was running the company. It's a really good matching unit for matching end-fed wires or balanced wires or doublets. It will match just about anything, really high impedances. So we'll have a look at what it is, how it works, and why you should consider this versatile tuning unit. Again, it's a good building project, and you can still buy these on eBay for about 60 quid. It's designed for true balanced operation. Not many matching units these days are. They'll have a really cheap voltage balance in the back, but this thing goes straight out and balanced line. So if you have a balanced antenna, this is the thing for you. And then on the 4th to 25th, we are going to be running, hopefully, the Hadar's Build-a-thon, which will be little row receiver. Talk you through building it on the first day, and then we'll have 3 weeks of watching the kit come together. Points to watch during construction, things to bring with you, and help. There are a couple of components on this board, particularly down here where it's not particularly well marked. However, at the moment, Kanga has been having problems with his family. The shop has been shut since before Christmas, and he's rumoured to be opening on the 19th of January. What the state of his stock will be like on the 19th of January, I don't know. So what I'm going to do is I'll ride this through until the end of January, and if I haven't got a definite answer from Kanga, I will come back to you and tell people who've paid a deposit either to take the deposit back until we know more later in the year, or to hang on to it, and we'll try and push the project out into May or June. But we'll have to, it'll all have to depend on what Kanga is doing and whether he remains in business and can actually keep on trading. And then we're going to do some CW on 8th of April. Learn firsthand why CW is not a forgotten communication method. Watch a demonstration of CW on the club radio and get to know why it is still a very useful and popular mode, and of course how to learn CW. All there to be had. And on the 22nd of April, we'll be looking at what we call the improved Rybakov. It's how you get the best out of an end-fed random wire vertical. There are ways of doing this. The Rybakov is not a particularly efficient antenna. I'm going to show you how to make it far more efficient. There we go. Look at the main areas of loss and how to get around them, and the hints and tricks of building one. So ladies and gentlemen, thank you very much for your attention. I'm sorry we missed the meeting last week through the dreadful weather, but thank you for attending, and I'm glad you enjoyed the talk.